Before we can start producing drawings in AutoCAD, we've got to understand how the drawings are set out. It's because we're drawing in 2 dimensions, we're not doing 3-dimensional drawings, we can only ever see 2 dimensions, either a length and a width, or a length and a height, or a width and a length. So when we present drawings, we've got to be able to show every feature that we possibly can and what is required to be able to communicate our design to the person that's making it. That's always the end result with any drawing exercise. It's a way of communication of your design ideas to be able to give it to the person who will actually fabricate it, be it an engineering object, or be it an architectural object, or any of the other fields that drawings are required in. We have to be able to present all the information we need on a 2-dimensional sheet of paper. We do not dimension 3-dimensional drawings. They are what's called pictorial, because it gives you you can see all the 3 dimensions, a height, a width and a depth. But because when you draw them, it changes the lengths, because just of the nature of drawing isometrically and pictorially, the dimensions only go on 2-dimensional views. So we need to represent all of these correctly. Now, the way that that's done, we've got these features here that are called dihedral angles. You've got 2 planes that cross at 90 degrees. And when they cross, they make 4 angles. You've got the first angle at the top, second angle, third angle, and fourth angle. You imagine we were talking about the polar coordinates in AutoCAD, that it works in a 360 degree circle, and you had your first quadrant, second quadrant, third quadrant, and fourth quadrant. This works basically the same. We've got a first angle and a third angle. They're the 2 types of views that are used in drafting around the world. In Australia, we work in 3rd angle projection. So that's the one that we will focus on now. I'll explain a little bit about first angle projection, because it's basically the same, but you'll get a different type of view. If you draw first angle in Australia, the problem is that the people in the fabrication industries are all trained to read drawings in 3rd angle. There's a possibility if you draw in first angle, they will read it back to front. So it's important that when you do things, it's done in 3rd angle projection. So not to confuse seeing the both of these, I'll just open up 3rd angle projection so that we can see what happens. Basically what you look at is if you've got a box, if it's made out of glass or a clear material, those 2 planes where you had a vertical plane and a horizontal plane, the planes are common between first angle and 3rd angle. See this one at the back here? In first angle, it was up above it diagonally, but the vertical plane was the same on both of them. What happens is that when you have the plane side, you've got top, bottom, and 2 sides, and the back. Where that's shown there, this is considered to be the front view. Whenever you've done your drawing, you look at it this side, where it projects onto the face is the front view. So what you can see there is that basically the face of this yellow object is projected onto this clear glass panel. What you can see on this face, you can see on the clear glass panel. Same goes on the left-hand side here. What you can see on the yellow block, you can see projected onto the left-hand side panel. So you can see the bottom rectangle is this face here. This line is actually just this line here. That's all you can see. But this surface up here, you can see that complete surface. We roll it around, you can only actually see this face because you see that solid face there is projected onto that edge. On the top, whatever you can see on here is projected up. So this line here is this line, or it could be this line and that line. When you're looking down on top, you can't see there's a difference. It's only when we turn it, start to get pictorial, you can see there's a difference. But when we look directly down on top, we can only see those individual lines. We can see this edge here is this line. This line here is this whole edge. But you can't see there's a difference in height there. That's the reason why in two-dimensional drawings we have to give every view that shows the actual shape. If we only had a top view, you'd think that was only a rectangle. That's basically all you'd see is those two lines, but you wouldn't know how high those lines were until we put it in that view. You can see the height and the length. In this view, you can see the length and the width, but you can't see the height. That's why the requirement for to be able to see all the views. Now, when we have these views projected, what happens then is that the box is laid out. And that is how you will see your drawings. In orthographic projection, that's what this is called, you'll see the front view, and on the right hand side, which is what you would be looking at from the right hand side, that is what you see. You remember you can't see how this height here on this side, so all you will see is that. You can see this line, you can see that cutout, you can see that line. That's the difference between this side and that side, is that on this side you can see the line. So whatever side that you're looking at, this view is looking at it from this side. This view here is looking at it from this side. The top view is looking at it from above, and you'll see that it's directly above. This isn't over here somewhere, it is directly above. This is directly to the side. If we drew a straight line across, these would be in exactly the same place. Same as this. It's incredibly important that everything is completely in line. That's what orthographic, remember in the first tutorial for AutoCAD, I talked about the ortho setting for drawing the lines in AutoCAD. It will only allow you to draw vertically and horizontally. This is orthographic projection. It's completely in line horizontally and completely in line vertically. Now you can see every view of this block is represented on one of these drawings. Some of them, these ones here have got height and width, both of them. These ones have length and width. This one has length and height. So every measurement is represented on each view. Now you'll notice on this here where it says third angle, when you see a drawing that's represented as third angle projection, you'll see this. There's a cone, a truncated cone, and to the left of it is two circles. When you're looking at this, and if you looked from the side of the two circles, that's what you will see. That's what represents third angle projection. That the side the drawing is on is what it is looking like when you look from these circles at that truncated cone. That is the important thing. We need to remember this when we're drawing in AutoCAD. Anywhere where we do two-dimensional drawings and we're doing this orthographic projection, that is how it must look. It has to be third angle projection in Australia. I'll just briefly show you the first angle projection so that you can see the difference. I'll just close that back up again so it's back in its box. This is first angle. I'll close it up again. So you'll notice that it's still, the glass plate is to there, but whereas this one we're looking at from this way, the previous third angle one was down in this quadrant here. This is the first angle, so it's between 0 and 90. This one was between 180 and 270. If you remember those degrees in a circle that we talked about in the second tutorial for AutoCAD. Now you'll see, because it's projecting back onto a different plane, whereas on the third angle it was this face it was projecting onto, what we see on this side is projected back on this one where we got the first angle will be the front view. At the side view we're looking from this way and it's projected on to the sheet. This way, this face where it was projected back towards your right in third angle projection, it's projected to the left in first angle projection. And what you see on the bottom plane is what you see from the top of the object in first angle projection. Now when I open this out, you'll see the way that it turns out in first angle projection. And you'll notice the difference between these symbols. It's still got the truncated cone, but on this one, the circles are on the opposite side. So what you see in first angle projection is what you see from looking from this direction. You'll see those two circles. Whereas in third angle projection, the two circles were over on this side. So it means that what you see from this side is drawn on this side. That's the difference between first angle and third angle. You'll notice here that this line represents this line here. On the bottom view, this line represents this line, and this line here could be a combination of the top and that level or this bottom level line. But it's shown on the bottom view is what you see from the top. The top view is what you see from the bottom. It's projected upwards. This one here, what's seen from this side is projected onto that panel, and vice versa, what's seen on this side is projected onto that panel. So the way that you look at your drawings, that's here why I said that somebody working in first angle projection, the drawing done in first angle projection given to somebody that works in third angle projection, they would see this back to front. Normally a good tradesman will pick that up and say, hey, this just doesn't look right, because they'll see this shape and then it will be different. But if they're not really switched on for some reason or other on that particular day, a mistake can be made. Whereas if the drawings, and then the draftsman could be blamed for it, that it was drawn in the wrong projection for Australia. The Australian standard for drawing is that it's all done in third angle projection. I don't need to show you much more about this so that you don't get confused with it, but it's important that everything is done in third angle projection. When you get more experience in the actual drafting, you will understand this even more. Sometimes it takes a bit to get your head around it, but this is a pretty big area of knowledge doing drafting. So we'll move on to some AutoCAD now and put this theory into action. Okay, so now we're going to put the dihedral angle, the orthographic projection, into practice. Now I've drawn up that block similar to what was in the previous video, but it's a three-dimensional object. What I've done here, I've put dimensions on a three-dimensional object, which is generally a no-no, but I have to be able to give you dimensions to be able to draw, and I will provide this model to you so that when you get to practice it, you'll have these dimensions. Now I've drawn what you can see here that I've got pictured as the front view. You can see that there now. You can see the bottom line here is the horizontal line. You'll see everything's horizontal and vertical. there's none of these angles. This is called an isometric view or a pictorial view that's drawn all of these angles. If you add these three angles together in a circle, each one of them is 120 degrees. I've got this drawn, the front view. Now we've got to do our orthographic projection to have a view from either side. Like just from this view alone, you can't tell the depth of the object, how deep this cut is, how long that piece is. So you can only get a certain amount of dimensions off this one view. We've got to be able to provide every view that will give you a full idea of what this object's going to look like. So with our layers, what I've done, I've made a layer called construction, because we need what's called construction lines. They're a different type of line. It's so that we can project out the different positions, the parts of this, without it being a proper line. But remember, with these layers, when I'm finished doing my actual drawing, I can turn the construction layer off so that it won't be seen. But you don't have to go through and delete them all. All I have to do is turn off that layer. I've also got a hidden layer. That's for hidden lines, because there's some of these lines in different views you will not be able to see the line. So what they do, the protocol, is to do a dashed line which represents hidden detail. So I've got a hidden line. I'll show you that further in the video so we can understand the layers that you've got to create. Okay, what we're going to start off with, I've got it on the construction layer. All I've got to do is select the layer that I want them on. The geometry layer, all of these, if I select that, it's on the geometry layer. If I put it back on the construction layer and I select this, you see how it picks the geometry layer. It tells me that that's on the geometry. And every line that I want to draw for this will be on the geometry layer. But what I've got to do first, the construction lines, I've gone the construction layer, I drop down this dial like this here that says draw. These particular lines here, these are spline fit and a spline CV, but this one here is the actual construction line. This one here is a ray, it's a different sort of thing for different drawing. But the construction line, and I've got it so that the layer is a dotted line so I can tell the difference. Now you notice how it locks on vertical lines. And a construction line goes infinitely. It's got no dimension, it just keeps going forever and ever. So every line that we need to project, I need to create a construction line for. We'll only need that one there for horizontally, that one there horizontally, and this one here vertically. So every line that we need in the construction line, so that we can project it up onto the view, we need to have our lines like that. So we have to be able to set our views a certain distance apart. So it's not just a random thing. I'm going to make these 50 millimeters apart, and I simply have to do a 50 millimeter radius circle, and that will give me the point where that is. I can now once again do my construction line vertically. When we do orthographic projections, so that we know that the lines are going to be in exactly the same place, the same distance out to the side and up to the top, what we do is we draw a 45-degree line. I can just tab that through. I'll just enter, it will specify that one. Do that again. I know it locks on to 45. There's my 45. I just click it and I know that line's on 45. If I wanted to know that it's really accurate, I go to Settings, Polar Tracking, and see here I've got additional angles. If I tick that additional angle and click OK, and I'll do this again, I'll delete that construction line. And if I draw that again, because I've got that selected, it'll actually lock on to 40. Excuse me. It'll actually lock on to 45, so I know that it's there. When I want to continue on, because these lines are projected up, if I go through on that one, that'll be this inside line. I know that this here is 75. I zoom, it's 75 wide because this front here is 100 millimeters. So I've measured that at being 100 millimeters. That's 100. And this here is 50, and I don't have a height on that one. But if I pick this dimension here and that there, what do I need to do here? That's not a true dimension. I know that's 100 anyway. So that height there is 100 as well. That's the thing with dimensioning isometric views. The actual dimensions are shortened, so you don't get the right measurement, whereas I know this one is 50. And I know it's 100 high. So because I'm going to now, I want to draw geometry, I've got to change the layer to geometry, and that will give me a solid line. I know that this edge here, we've got to go up 50 because what we're looking at now is from this direction. So we know that it goes up 50. Type 50. I can draw this section here now. I know that it goes 37.5. If I do another construction line, I missed this one here, I didn't hear anybody tell me. Is that construction line there? So that gives me the height. Change this back to geometry. Now I simply take this line up to there, and I know from this here that it's another 37.5. 37.5. I go. Went on the wrong angle. Big fingers. Now this one goes down to the bottom and back to there. And we can also see this line through here. We'll see this edge. So we'll draw another line through there. So you can see this, that's what we see from this side. From this side, we're looking, the front view is looking from this, where I've got the arrow, is the front view. In third angle projection, it's what you look at from this side is what you see here. So that we can see that edge, because you can see, you'll be able to see that, you'll be able to see that line, which is this, and you'll be able to see that cutout. So that's the third angle projection for the right hand side view. Now what we do now is that we've got these, we go back onto the construction layer, pick construction lines. Now we shoot this one up vertically, this one. Once we've got them, then we pick this intersection and take it back that way. So we know now that this has to be directly over the top. So I'm just going to draw a rectangle so that you can get an idea. What we can see from up above here is actually in here. See how these two lines project up, so you'll see those two edges. These ones here project across, so we're right now, this measurement here is the same as this, and this measurement here is the same as this. And all we have to do now to get what we can see on the top view is draw that line there and draw a line here, because that's what you will see looking directly down on top. You can't tell, in this view, you can't tell how deep that cutout is. You can see there must be a cutout there because you've got a line. If you didn't have this view here, you wouldn't be able to tell what that line's for or what that line's for. But because you can see this view, you can see, oh, well, it's got that big cutout in it. So once again, if we put a 45-degree angle line up through here, and this will lock on to 135. No, I haven't got 135 on there. I would have to change my settings. I've still got that on. I didn't change that to construction. So you always got to remember to change it to the line. Pick the construction line. $135. Now, if I project these lines down, go back to, I can use construction again. Pick these points, go down. This one. Because what we're going to see is this width here, the same width as that. So if I change this back to geometry, we'll be able to draw that rectangle, and it'll be exactly the same size as that. It's the same distance apart. All these are the same distance apart. But the only difference now is looking from this side, we can't see that line. We can't see that line. So what I've got to do is change this to hidden layer, and I will just draw a straight line along here. See how it's dashed? That's what it means. That tells you that there's something behind that, which is this cutout here. If we just saw that block there, if we didn't have you should be able to figure that out, really. But what we need now is another construction line to be able to get this line here, which projects this down. It's projected through here. So we change it back to geometry, draw this line, have a line down to there, and a line out to there. But we don't need these lines, so what we do is we go up to the trim command, select these two here, enter, and trim that out. And that's what you would see looking from this side onto there. Looking down from the top, that's what you would see. Looking from the right hand side, that's what you would see. And what I'll do now to demonstrate is I will turn the construction layer off, and there's our orthographic projection. You see the top view is directly above, it's not over here somewhere. The right hand view is directly the same height, the same as the left hand view. That is called orthographic projection. So this will be the first exercise I'll get you to do. I will provide you this drawing, and you need to produce the orthographic view of that. This being the front view, you've got two side views and a top view. Now, just to tell you about the layers, I know it's a little bit different on 2020. It's called Layer Manager, and you click that. What I do is this one here, it gives you a new layer. You can just click the new layer. What it does is it will always do, where it puts it, it'll always be just below the current layer, and it gives you the same properties as the current layer. What I've got up here is the construction. When I click on line type, I'll go back and do this again. In this one here, click on continuous. It's got the different sorts of line types that I've already loaded into this here. When I first began, this was empty, and you have to load your different types of line types. If you click load, that brings up all of these. That's in the AutoCad ISO. That's why it's good if you stay within the AutoCad ISO. We're all working in the same place. And you have all these different line types that you can load. It's got one there that's called hidden, and I'm pretty sure I picked hidden 0.5. It doesn't matter which one you do. If it doesn't show up in your drawing, you can always see there's three different types. And construction, there isn't one in here for construction, but all I did was I picked the, the dot. It was just a straightforward dot that I selected for that. It's here somewhere, you'll find it. There's dot. So I just selected that one for the construction line, just so that I can tell the difference between the lines. Some people leave them all the same lines. They just might change the colour. If you click on that one, they're all white. You can change it to green or whatever colour that you like. It doesn't make any difference, but it just helps you to identify the line. Like now, if I turn construction back on, it'll be the same line, but it'll be green. That helps you to tell the difference. But I can turn the construction layer off, and that just gives you a geometry. So you'll want to create a layer for construction and for hidden detail, just hidden line, and one for specifically for geometry, so that you can turn it off if you want to. So you always leave yourself room so you can turn stuff off if you want to, but you can always turn it back on again. Okay, have a go at that. Have fun.